Hi everyone, welcome back to the Cubers 5002 Excel tutorial video series. In today's episode, we'll be looking at how to perform a regression analysis using Excel and as well as the Excel Adding Data Analysis Plus. We'll begin with our dataset. This is a dataset based on the assignment, Cubers 5002 assignment. As you can see, I've modified the raw numbers so it has no resemblance to your group assignment, but the structure of the data set remains consistent. We'll begin with the Excel built-in data analysis function. We go to data analysis, regression. Here we need to input the Y range. In this assignment and in my sample data set, I have labeled my dependent variable, that is my Y variable already. But in real life, it is likely that you might need to identify your Y variable. But let's highlight our Y variable first. And we'll tick label because we've included labels in our selection. And then we'll go to the X variable. Because this is a multiple linear regression, we have 8 independent variables, and we'll highlight them all. And we want to build our model in a new ply. So let's name our new ply the base model Excel. And let's tick all of these boxes. The reason I tick all these boxes, although we might not necessarily need all these plots, it is easier to have them generated to begin with rather than trying to come back and regenerate them later on. And we'll press OK. Here is our multiple linear regression. I'm sure this is a familiar sight to a lot of you already. We have here R squared, which measures the percentage of the variation that is explained by our model. And we can see this R squared is fairly low, only 6.5%. And we can look at our SSR and SSE and SST. We can see our SSR is very low, only 3,000, less than 3,000, whereas the SST is over nearly 46,000. But of course, we know the relationship between these numbers is our R squared is SSR over SST. And here we can see our independent variables, their explanatory power, by looking at the p-value. Because we know this p-value is essentially a hypothesis test where the null hypothesis is that beta equals to 0, and the alternative being beta not equals to 0. And because we have a high p-value, we do not reject our null hypothesis, which is that beta equals to 0. And we would like our betas to be unequal 0, because that having beta equals to 0 would suggest there is no linear relationship between the independent variable and the dependent variable. This residual output will help us to perform the diagnostic test to our multiple linear regression. That is first of all the same as our simple linear regression: linearity, independence of error, normality of error, and equivariance of error. That is also homoscedasticity. Because we're dealing with a multiple linear regression, we should be also aware of issues such as multicollinearity, and we would need to perform appropriate tests for that. Next, we will perform a stepwise regression using the data analysis plus function. So we go to adding data analysis plus. We find our stepwise regression. Just a side note, the stepwise regression may only work on a PC and it may not work on a Mac, so just be aware of that. You might need to complete this step on one of the lab computers if you're using a Mac. It's okay, check for missing values. That's not necessary. We have all our values are complete in our data set. Here we need to select our response variable. It is also our dependent variable. It's also our prediction. And here we note it should not be a 0 or 1 dummy variable. So that would be a logistic regression. That is not what we are concerned with. And here we need to select our explanatory variable. That is also our independent variables. So you might have noticed a lot of these terms are interchangeable, and it's just up to the preference, but they all mean the same thing. So here we need to hold shift to select multiple, and press OK. Here we'll use the p-value method. So remember, this is a stepwise regression, so the computer will automatically compute the regression, the multiple linear regression, by removing or adding the variables from the regression model in order to improve the model. So we'll use the p-value method. Here you'll need to select the p-values for Excel or DAP to complete a stepwise regression. The default, you should continue with the default values, that is 5% and 10%, in order to assess whether a variable is has an explanatory power. Because I am using a altered data set, I've tested this and I'll need to adopt a slightly different value in order for this to work. But you should use 5% and 10% here. Tick box as appropriate. Would you like to new worksheet, please? So I think in terms of best practice, it's always safer to work with a new worksheet rather than the existing worksheet, so you don't run the risk of contaminating your data. And like I said, always save multiple copies, because you will never know when Excel decides to crash. So I've named this base model DAP and press OK. So here you see, this is the stepwise regression. So Excel starts with the first variable and then continues to add variables to the model. So here we have 2 variables, 3, 4, 5. Okay. So here Excel has decided to stop adding variables because I've indicated because adding more variables would not satisfy a requirement that the p-value satisfied the p-value requirement. So I've inputted value to add to be 0.5, whereas for you it should be 5%, so 0.05. And here is our now reduced model. Here now we have the restricted model. You might want to perform a statistic procedure to test the validity of this restricted model relative to the unrestricted model, and that the details of that has been covered in your lecture slide for week I believe is week 10. So please refer to that. Thank you, and I'll see you in the next episode.